On the last video, we talked about ionic bonds, and ionic bonds was when atoms transfer their electrons. You get a cation, anion, and the atoms stick together. Covalent bonds, on the other hand, are when atoms, two or more atoms, will share their electrons. So the electrons are going back and forth between the atoms, and so not one has it more than the other. Well, that's not necessarily true, because we will learn that there are different types of covalent bonds. There's one that's called a polar covalent bond, and that's where they don't share nice and even with one another, and there's a non-polar covalent bond where they share very evenly with one another. But either way, covalent bonds is where there's sharing, and I wanted to point out that that is when there is two or more nonmetals. We're going to stay with two nonmetals for our naming purposes, but if you have a bunch of nonmetals together, for example C6H12O6, which is the formula for glucose, that is a covalent bond because those are all nonmetals. So again, covalent, two or more nonmetals sharing their electrons. And then this says the same thing. I just wanted to show you. Here's oxygen. This is looking at a Bohr model, so you can see it pretty well. Oxygen has a valence of 6, and so you can see the 6 yellow dots there. And then hydrogen has a valence of 1, and his is green there. And so you can see that they're sharing. This one's sharing its green electron. It's not really green, and the oxygen sharing the yellow. Now the reason this is completing hydrogen, because hydrogen only has one energy level. So this is what water molecule looks like. They call it the Mickey Mouse molecule because it looks like the ears and the face of Mickey Mouse. But that is a covalent bond. And so we're going to learn how to write a formula name. Covalents are super easy. So we're again just going to do what we call a binary. Binary means it only is made of two different elements. And so they get more complicated when they have more. So the difference that we're going to see, if it's got two nonmetals, you're going to use prefixes. And so you're going to use prefixes to tell how many you have of the element. And we are still going to change the ending of the second element to IDE. So that is the same for both ionic and covalent. Here are our prefixes that we're going to use: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Those are for 1 through 10. They do go past 10, but we're just going to do the 1 through 10. And we will use those on both the first and second element, with the exception of mono. We do not ever use on the first element. For example, many of you do know that this is called carbon dioxide. It's not called monocarbon dioxide, it's just called carbon dioxide. We will use prefixes other than mono on the first element. So we're going to look at some examples. You may want to pause and write those down. Alright, so I just have two examples of each. And so I know this is water, and on this first test, or when we're doing the formula, it's called the IUPAC, which is the International System for Naming. The IUPAC name, we're going to actually call water by that. And so this test, this Unit 2 test, I would like you to use the formal name for water. This is actually ammonia. I would like you to use the formal name. And then later we'll start just calling this water and this ammonia. But not to be confused with ammonium, which is that NH4 positive 1 polyatomic. So there are two hydrogens, so you would say di. And then the first element, you just write the element name, so you're not going to change the ending of the first nonmetal. So dihydrogen, and this is one oxygen, and so we would think, well, it's mono for one, but the fact that it's oxygen, we're going to change it to IDE. Do you see how those two O's come together? That kind of looks funny. And so that would be monoxide. So anytime you have a vowel here, most of the time that ending prefix will just drop out of there. So you get monoxide. So dihydrogen monoxide, the formal name for water. Alright, so we have one nitrogen. Again, we don't say mono, so we're just going to say nitrogen. But there are three hydrogens, so we're going to use the prefix tri. And then hydrogen, instead of be hydrogen, is going to be hydride. Not hydroxide. Hydroxide is a polyatomic that has oxygen and hydrogen in it. So hydride, nitrogen trihydride. And then to write the formula, you just write whatever it says. You don't switch them. You don't use oxidation numbers. Those oxidation numbers are the charge of the ions. This is covalent. And you know it's covalent because this is a nonmetal and a nonmetal, nonmetal, nonmetal. Phosphorus is a nonmetal, oxygen is nonmetal. So two nonmetals is going to be a covalent. We'll get to hydrogen in a moment. But so diphosphorus is going to be P2. And then pent, notice the A is gone instead of penta. We dropped the A out of there because there's that O. So pent oxide, pent being 5. Don't swap them. You wouldn't reduce them either. If it had been tetraoxide or tet-oxide, you would write it just like that. So you don't reduce these. So you only reduce for the ionic compounds. And the ionic compounds are called formula units. This is actually called a molecule, a word that we use for covalent. So this is a molecule. It's a water molecule, an ammonia molecule. So carbon, tetrachloride, carbon would be C, tetra would be 4, so tetrachloride would be CCl4. And that is covalent. You use prefixes if they're two nonmetals. Okay, two nonmetals. So if you have a metal in it, it's going to be an ionic compound, and we don't use prefixes with that. All right, since this is such an easy lesson, I'm going to teach you the very basics of hydrocarbons as well. So a hydrocarbon is a special type of covalent compound that has just two elements. It has carbon and hydrogen. They are called hydrocarbons, but carbon's going to be written first and hydrogen's going to be written second. And the ones that we're going to do today are actually going to be called an alkane. And if you have to take organic, you'll learn alkanes and alkenes. We're going to do alkanes because our hydrocarbons are all going to be an A-N-E ending, an ane ending. Whoops, don't know what happened there. I'm so sorry. Back to that. There we go. Pushed the wrong button. All right, you may want to pause or write this down. We're going to be writing the formula using the appropriate prefix for the number of carbons. Carbon is going to have the prefix. We're going to learn how to calculate the number of hydrogens. It's going to be the number of carbons times 2 plus 2. So you can remember times 2 plus 2. That's how we're going to get an alkane's number of hydrogens. And then these words are all going to end in a suffix of ane. And that's going to be connected to the correct prefix. These are super easy. There's our prefixes that we're going to use. And so you can see that pent, hex, hept, oct, non, and dec. So 5 through 10 share the same prefixes as covalent because it is a type of covalent. It's just these first 4 that are different. And so this is meth, eth, prop, and bute. We are going to be putting the prefix ane on them. So this is going to be methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. You've heard of a few of those. You've heard of methane gas. That's what's on Bunsen burners. You've heard of propane gas. I will tell you the first 3 are gases, and then 4 through 10 are actually liquid at room temperature. So meth, eth, prop, bute. I have students that always get those mixed up like order-wise. And I had a student many years ago. Her name was Meredith, and her 2 best friends, they all 3 ran together, and they did love each other. But Meredith was extremely allergic to peanut butter, and so they made up this little mnemonic: Meredith eats peanut butter. And then they looked at her and said, and then she died. So that I know that's silly, but it has stuck. So Meredith eats peanut butter is 1, 2, 3, 4 to help you remember meth, eth, prop, and bute. Methane, ethane, propane, butane. I don't have anything for the others because the others are the same as covalent, so hopefully you can memorize these. So they're not that bad. All right, so I have an example of each. So I know they're hydrocarbons. I know these are hydrocarbons because they have carbon, hydrogen, carbon, hydrogen, carbon, hydrogen. Very easy to see here. I know these because they're just one word and they end in ane. So this is what we call an alkane. And so these are going to be C and H, C and H, and C and H. All right. So meth, means that there's one carbon. Eth means that there's two carbons. Prop means that there's three carbons. That prefix is the number of carbons. To figure out the number of hydrogens, you're going to take the number of carbons, so it's the number of carbons times 2 plus 2. So for this one, 1 times 2 plus 2. So 2 plus 2 is 4. So methane is CH4. The ones we don't write. You may write the one if you like. Alright, so ethane would be 2 times 2 plus 2. So 4 plus 2, you would see C2H6. 3 times 2 is 6, plus 2 is 8. So you can see a pattern going on there. So propane C3H8. So this one, it's named by the number of carbons, not by the number of hydrogens. The ain part is the number of hydrogen. Can you see that's times 2 plus 2 though? Because times 2 would be 10 plus 2 would be 12. So this is 5 is pent, so this is pentane. 10 is dec, like a decade, and so this is decane. And 4 is bute, not but bute, and so this is butane, like a butane lighter. And so that is your hydrocarbons. And that is really all there is to covalence. So we did covalence and then a special type of covalent known as an alkane hydrocarbon. Hopefully this makes sense.